Alright, draft physics video. Take two. Yeah, I don't do that too often, but so I got in trouble. Anyway, and that's the whole point of the video, is that I'm trying to work through, trying to resolve these issues that come up where people don't really understand what I'm talking about, and I don't see how they can not understand it. And so I have to do better at explaining. And so I was thinking, and the website has it sort of written out, and I got to fix some of that because it's still not perfectly correct. But that I could do videos just for sections of the website, just each idea, and that way, if somebody has a problem with something I'm saying, they could just play the video and get more context, and maybe they'll understand what I'm saying. So anyway, just annotate my own content. Um, yeah, so there's been a couple of comments that are sort of indicate that kind of problem, and and there's some things I've been thinking about just in terms of explaining the nature of this. Well, I'll read the comment and then I'll do the explanation, as I attempted it the other way and it didn't work. So anyway, Bob Hicks says, Gary, if you choose to abandon the word tons, your own invention, in favor of bits of matter or bits of force, that's okay with me. Well, I'm glad it's okay with you. It's not really something I wanted to do. It's just that it seems that I have to do it because people just didn't want to recognize that distinction and the force idea, and it was just something they mocked. So what's the point? There are some other reasons, like electron and proton. Those words aren't compatible with the idea of tons, because tons would have nothing to do with electrons and protons, and then that's the difference between force and matter. The force bit would have been the tons, and the matter bits would have been non-tons. They would have been whatever, electons or something bigger. But anyway, I am just trying to communicate in a common language. Yes, bits of matter is understandable to me. Good. I can touch matter, but I'm having trouble trying to understand what you mean by force. Well, I've sort of said it. You can see light, and light is a force. Light isn't made out of matter bits. It's made out of the force bits moving the speed of light. So every force that's conveyed from one thing to another thing that we know of, that isn't something like electrons moving, right? We call that a force when electrons move, like, I don't know, lightning or something. And it's not really a force. The force bits are moving the electrons, and the force bits are moving through the electrons. They're moving past them. The force bits are the stream. So if you use the Einstein analogy of the bent fabric, which is really a convergence, what's converging are the force bits, this stuff. So it's just this stuff. It's just little quanta. And as I said in the other video, they're all the same. So whether it's light, or it's magnetism, or it's gravity, those are the three biggies, or the nuclear forces, because these are the same things. The same little things are doing it all. The force bits are all the same, and all they are is black and red, or polarized left-right, however you want it. They're two distinct polarizations, two distinct types. And those two distinct types are filtered by electrons and protons, as I pointed out. And it's that filtering, and how well it's filtered. The stronger the filter, the more perfectly it's filtered, the more powerful the force. So on the nuclear level, it's very personal, very pure. On the magnetic level, it's much less pure, but still really pure. And on the gravitational level, it's the least pure, in that there's not as much segregation of the force, and therefore it can't create as powerful attraction and repulsion. Technically. I mean, it can't create repulsion because you have to have the segregation for repulsion. It's mandatory. There's a point where if you don't have segregation, you're not going to have repulsion. Anyway, so anyway, bits of matter is understandable to me. Okay, I can touch matter. But okay, read that part. Matter in motion has force, momentum. Yeah, well, see, they've always used the word momentum as if you could acquire it just as something you have. You don't have to actually something physically change. You just have momentum. And the point is that what you have when you have momentum is you have force. That's right, you've collected it. So read your statement again. Matter in motion has force. So I'd agree with that in the sense that it's captured the identity of a force, in the sense that it has replaced in it force going the wrong way for force going the way of the motion. So it has a disproportional, an imbalance in its force. So it's an imbalanced gyroscope, however you want to look. It's not doing what it was doing before. It's processing. It's definitely not staying still. Even matter at rest has force, inertia. So that's where I'll disagree with you in the sense that yes, it has force, but it's imperfect balance. So when it's at rest, it's in balance. And the only imbalance is the external world. So the piece of matter bit would be in perfect balance. It has stuff going this way, this way, all equal. So there's no movement in any direction. So I kind of thought of a way of illustrating that. I just don't. So if you had a stick and you had a string on it and you had a weight on it, the weight would point in the direction of your last motion, so to speak, where you moved last, or where you're moving, actually, relative to the stick. So it kind of will show your last motion relative to the stick. So we had like a globe, and you could put this little stick in there with a string on it. It would be an indicator of where you're moving. So if we took ourselves off Earth, we could see by turning it which motion, because it would undo the last motion and start moving in a new direction. And wherever we went, we could kind of see which our last velocity was. And it wouldn't be telling us our absolute velocity, because the stick got the same velocity absolutely as the thing, and it can't do that. All the older velocities will be eliminated. And the only way you could fix that is put a stick with a string and a ball, and then have a stick inside that ball with a string and a little ball inside of it. And you have to make this all big enough so that little velocities could be measured, little changes could be measured, because things they would be moving differently, because they wouldn't be impacting either the tension in the string or the surface of the ball, so to speak. They wouldn't hit something that would convey to them their new velocity. So you don't know your velocity until something hits you to tell you what it is. So if you were weightless in a spaceship, for example, and the spaceship moved left, if it moved left slow enough and the wall never hits you, then you don't move left. The spaceship could move right and it could move left, and you could just stay in there, and the spaceship could be moved all around you without hitting you, so you never change your velocity. So it's not until force hits you that you can collect it. So it's that kind of obvious. The force has to hit you. You have to be hit by it to collect it. And when it's inside a piece of matter, you have to actually make contact usually to get a piece of the force, unless it's radiating heat or something. You have to actually make contact with it. And because it's inside. It's not on the outside, it's on the inside. It's trapped in the atoms of the material, the inertia. And so I have to come up with a better way of saying that, but that's the point I've always made, is that these are the only things moving in the universe by themselves. The matter bits, their, say, native state is not moving. And it's actually like that, because even when you start to move them, they'll lose that velocity very quickly, because the system's always hitting them. And it's going to tend to force them into balance just by the laws of probability. And so it's only because of the special arrangements inside of matter where you can place more mass on one side of an atom than you can the other side. That is, you can have all the electrons on this side and no electrons on the other side of a rotation of a square. And you can sort of understand that if you have a square like that, all the mass is on this side getting moved this way, and there's no mass on this side getting moved that way, that square would end up moving in that direction, in the direction of where the mass is moving, the electrons. And so that's the acquisition of velocity. But it's always the force that causes it, and you just absorb it. And so it's not your motion, it's the motion of the force that moves you. Captured force. Alright. But force in and of itself is not something that can be I can comprehend. Well, like I said, just think of it as little bits. That's why I called them force bits. Just think of them as bits of quanta. They have let's say a mass of a 1, we could call it, because they're all the same. And you're just getting hit by something with a mass of 1. So the more mass of 1 that comes into you, and like I said, when you're hit, it's an exchange. What's happening very really, is that the bit that goes in this way exchanges for one going that way. So it looks like a reflection from the outside. A bit going this way went in, and a BB or a bit came out this way. But what happened inside was you just exchanged. You said, I'll give you this guy because I don't want him, and I'll keep this guy. And when I kept this guy, I created an imbalance. I gave away one going this way, and I kept one going this way. So I'm going to tend to go this way. Think of it as a school of fish. I've used that analogy. You have a school of fish, and they're all going different ways, but they're all equally going in different ways. There's 10 going this way and 10 going that way, and 10 going this way and 10 going that way. And I throw a new fish in, and I exchange that fish for one going that way, or I exchange for one going that way. Then I'm going to change the net balance, and I'm going to have a net balance in this direction. Now I won't be going as fast as the fish was going, the speed of light. I'll be going the diluted across all of the fish speed. That's how much speed I'll gain, is how much I diluted the whole system. It gets blended into all the fish, and you add up what all the fish are doing as a percentage, and so you end up going 1 mile an hour, even though the fish that went in was going the speed of light, because you have to divide it into all the fish. The net product. Alright. Please clarify. Hope that helped. Overall, your theory seems to make sense, and I appreciate the time and effort you dedicate to responses. Thanks, Bob. Appreciate it. Yeah, so I don't know what else I could add. There's only one thing that's truly in motion. That's the force bits. Now, the complicated part is that matter bits are made of the force bits. All right, they're not free. So the force bits are free quanta, the matter bits are locked quanta, but they can exchange. So that's the key thing. So they're like stuck in a, I don't know, let's say it was a Rubik's Cube. Probably not a great, there's probably better examples. But matter bits are like a Rubik's Cube, and all the little squares are stuck. And the force bits are free little cubes. And the trick is the little cubes out here, okay, and let's say the Rubik's Cube had, instead of colors, it had arrows pointing in a direction. And so the little bits out here, the little squares out here can go in, hit the frozen bits, and they can kick one out and replace it inside and call itself, now I'm part of the matter bit. So the force bit becomes part of the matter bit, and it expels a new force bit going the wrong way. So it's going this way. This is the direction taken, and it gives back some direction in the other way. Alright, I hope that helps. But this whole idea of giving it back in the wrong direction in some direction that's opposite. Okay, so as a sphere has two halves, like the halves of a tennis ball, you can understand that anything in this direction counts as that direction, as a dimension. It's moving in that dimension, and it just exchanges anything can count. So anything you're getting rid of that's not a perfect this, anything that's less than perfect this, okay, is still going to be some positive in this direction. Like this is a negative to this in that direction. It's less than. So it changes the balance, and that's the inverse square law. It's basically when gravity comes in this way, it leaves going this way, this way, this way, this way. It leaves going all of those directions. And that's the inverse square law. It's the difference between this straight point and all of these points. So that's why gravity gets so weak, is because its response goes in all directions on that whole face of the tennis ball. Even though the action force went in straight, the reaction force comes out blended. And you can sort of understand that for all the ones that are going the wrong way, not perfectly straight back, they're exactly opposite on the other side, so they balance out to an average that's still going to be a straight line. It's like you got hit from two things, one going this way and one going this way. Your response is to go this way. The mass does the math. And it's really simple math. Alright. So, there was another comment I guess I could read. I think that's a satisfactory response. Alright, Tony Michael. The problem with you is you can never agree with anybody about anything. Well, it's just not true. I mean, the problem with me is that I think I'm right, and on some subjects I think I'm explicitly right. That is, I think I'm stating things as accurately as they get stated. And therefore, yes, I have some difficulty saying something stated not right, or imperfectly, or less perfectly, or less incorrectly, you could even say. Maybe I'm terrible, but everybody else seems worse at articulating truth. So I'm not going to, why would I concede or accept statements that are not exactly accurate? I mean, I sort of had this with Benatar's asymmetry, because I always called it a zero sum. That the best we could achieve was a zero sum, because everything we're doing is fixing a negative. We're not making any true positives. We're just correcting for negatives, and therefore can only get back to neutral if we're lucky. We're only climbing out of quicksand, so to speak. So that's two ways of saying it, though. There's no negative to the non-existence of an unneeded positive, that way of saying it, an asymmetry, or just saying, well, it's a zero sum. So I still think my zero sum argument is a better way of saying it. But I'll concede that Benatar's more effective. So, or at least has been. But maybe that's just because he wrote a book and he was a professor. But I still think it's the better way to understand it is to understand it as a zero sum. That the best you can achieve in a perfect life for yourself is a zero sum. Now, certainly in a world full of people in quicksand, you can be much more positive. You can have a very positive impact because you can pull other people out of quicksand, and therefore you can be very valuable. But for your own life, all you're doing is digging yourself out of the holes nature puts you in. But anyway, I'm just saying, I like things to be stated correctly, and the implication of your argument is that I have somehow dissed some sort of more correct way of describing something. And with this physics stuff, I haven't. So you can make your argument, but you got to quote some brilliant statement somebody made where I dumped on it, and it was better than how I described it, or better than how I theorize it to be. Okay. So he said, including myself. So somehow I never agree with myself, which obviously I think that's just you threw that in for fun, but that doesn't make any sense. So yeah, I'm dissing on that because I don't think that's at all accurate. I think I agree with myself a lot. You know, I go out of my way to be friendly and supportive. Well, it's okay, but I've sort of explained how I'm not doing friendly and supportive. I mean, I like it, but I'm in here, I'm in a war, all right? And you're showing up, you know, doing all kinds of homo stuff. And I'm like, hey, you know, it's a war. You don't got time for that, buddy. I just want somebody who knows how to shoot, you know, the little Nazi guys over there. You know, can you shoot straight and hit something? That's all you really, you know. I'm just not into the party time stuff. So, whatever. Sorry. Homie, don't do friendly and supportive. I appreciate it. Great. Thanks. But it's just not the game I'm in right now. My eyes are focused on the prize, so to speak, and the prize just ain't the friendly, supportive stuff. Of your stupid channel. Well, you know, is that being friendly and supportive? You call it a stupid channel? I mean, that sounds kind of rude and obnoxious to me. And this is the blowback I receive. Well, I'm sorry. I mean, I'm just being honest, and you think I'm being something other than honest, okay? So if you write a comment, I don't understand it, or I think it's really dumb, or I think, like I said, I've already been over this stuff, but I don't want to waste my time debunking. It's bad enough I have to debunk conventional science because it's full of shit, but I'm really not going to waste my time debunking every nutter in the universe who has some wacky theory. I mean, I just don't got enough hours in the day, you know, first to get up to speed on their wacky, and then to point out why their wacky is wacky. And especially when it's just stuff that's almost too religious, like the Tesla crap, where it's like these people who are in love with Tesla, they don't even know anything about Tesla. They just know, he makes a really great DC electric car. You know, sort of an irony, you know, that the Tesla car is named after Tesla and it's completely a DC system. It's a little bit funny. Anyway. Ironic. I guess ironic. Funnily ironic. Funronic. Okay. Let's see. So let me find out where I was again. I receive. Is there some way I'm not supposed to think you're an asshole? Well, no, you thinking I'm an asshole is fine. I have no problem with that. Thinking I'm dishonest or that I'm mean for the sake of it or some other kind of bullshit. Well, yeah, that's just being bullshitty, okay? I'm explaining why I'm an asshole because I'm on Earth. I'm living in idiocracy. And then even something as sacred as science, the idiocracy has gotten its tentacles into it and turned it into shit. And this is a nasty, crappy war, I mean, with complete imbeciles. I mean, they're stupid as fuck. And, you know, you can't, it's, you know, I'm not winning. You know, I can't make any headway on this stupid blob. It's like fighting the blob, you know, you throw a rock at it, it just eats the rock. You know, poke it with a stick, it just fixes the hole. I mean, it's a really tough adversary. It's got no fucking brain, and it can't do any fucking logic. And all I have as weapons is my logic. That's all I got as a weapon is these words and sentences and trying to compose them so they can understand why it's reasonable to say the evidence is weak. But that's the reasonable thing to say. Fuck. Alright, anyway. Tony again. You never conceded that light carries two velocities at once. I never said you conceded this. Well, you said, why did you concede in your comment? That's what you said. You're not paying attention. Well, I'm trying to pay attention. You're not writing attentionable material. What I said was you should not have conceded that it is possible to shoot light out of a window of a spaceship traveling close to the speed of light. Well, see, that's technically not a correct way to say it. See, technically what I would say is if you're moving in a spaceship going the speed of light, you don't have a gun anymore, you don't have a laser beam, you don't have any material objects anymore because matter can't move the speed of light. so you can't do it in the first place. So you have to say something like very fast, 3/4 of the speed of light. What happens to the laser? So I'm still going to argue that materially things would be in dicey condition. So you might not even be able to get the laser to turn on. Okay, but let's say you can. I never conceded that the laser beam shoots out crooked. I conceded that I can't prove that it doesn't. That's what I conceded. I can't show another piece of evidence from the real world that demonstrates that it's not possible that photons will do the headlight effect. That's what I conceded, is I can't defeat their mush. Oh, fuck. That was your argument. Well, it wasn't my argument. That it was impossible to shoot light out of a window of a spaceship traveling close to the speed of light, but not equal to the speed of light. When I changed the paraphrase, thank you. Even if you point the laser towards forward like a sniper shooting. Well, you would actually be pointing it backwards, but regardless. I didn't concede that it's the truth. All I conceded was I can't prove their God is bullshit. How many times do I have to say this? I believe that if you did have a laser and it worked, the light would go perfectly straight across, perpendicular, okay? And that's what it would do. It wouldn't go forward. It wouldn't, well, it would look like it was going backwards from a true neutral observer. In the sense the walls of the spaceship would fast disappear. The light would go straight, the wall of the spaceship would be moving and going away, and the light would have to be aimed, yes, well forward of the ship to actually go through a window, for example. But all I'm saying is I've never changed my opinion. Light travels independently of its emitter. The emitter can't give it velocity. It already has its velocity. The emitter isn't creating light, it's releasing light. The light already has a velocity. So you can't change it. Alright. So I never changed any of those statements. Tony. Shit. Okay, shooting into the wind. Right, yes. That's what you would have to do if you wanted to go through a window, or more precisely, as I argued, if there was a hole in the side of the ship, you couldn't hit the hole. You know, the hole would disappear before the light got to it. Then you unequivocally redacted this position. I didn't do any of this. So you're saying, why are you being an obnoxious asshole? Because you're being an asshole. I didn't do any of that shit. So you're saying I'm misunderstanding you. No, you're misquoting me, because that never fucking happened. Yes, you actually conceded a point. No, I didn't, you fuck. Sorry if this is too complicated for you to follow. No, it's not too complicated. I'm saying fuck you. I never believed any differently. I conceded only points of argument that I can't provide evidence demonstrating that their quackery isn't bullshit. Their God, it doesn't exist. You know, sorry if this is being an asshole, but fuck you! Sorry if this is too complicated for you to follow. Why don't you provide a fucking quote, you fucking cunt? I really did make my comment in good faith. Well, this isn't in good faith. You don't quote where I said any of this shit you put in my mouth, you motherfucker, and then you tell me that's good faith. Well, fuck you. And your spineless, whiny response here is totally uncalled for. You're fucking stupid. There. Are we done now? No. Quote where I conceded that light actually moves forward. Quote where I did that. All on its own. The photons know where to go. Quote it! Because it didn't happen. Except in your deluded little mushy brain. So, Robin Evans, a strange player here, I think. But anyway, he's usually on the Inmendum channel. What he said in this video, as far as I could hear, is that all he conceded was that he cannot prove that he that if he moves a laser beam at the speed of light that it will not bend like people theorize, because he cannot prove it is impossible to shoot light out of the window of the spaceship traveling close to the speed of light. Exactly. Correct me if I'm wrong. Maybe I wasn't paying enough attention. Seriously, though, I have no idea about the validity of Gary's theory. Well, you should. It's Gary's theory. Gary's always right. Yes, he's always right. As someone who has put little effort and time into studying or even thinking about physics at all, but he is clearly incredibly consistent, and you clearly cannot even follow a simple dialogue and like to ramble nonsense. Well, that's probably excessive. I don't think he likes to ramble nonsense. I just think it's, some people do that. They, they drool a little or something. But anyway, I don't fault his intent. I'm just saying he's obviously being, if you're going to be that aggressive in making accusations, you ought to make sure you got a good pile of evidence. You got a bag of evidence to throw at me. So Robin Evans again. Tesla was a decent inventor, engineer, but the cult conspiracy nonsense that is built up around him is silly as fuck. Yeah, it really is. And again, I'm not saying he wasn't. He was a good thinker. He had some good qualities. But this idea that he is the pinnacle of the that he achieved the millennial man kind of status or deserves that kind of accolade is just so insipidly crazy, compared to his peers. And he was just such a petty little potty mouth. I mean, he didn't make arguments, he just insulted people, when they didn't agree with him. So, I mean, he really wasn't, the man. Now, this is an interesting quote from Mark Twain. And if it's about Tesla, that really is interesting, because Mark Twain was a friend of Tesla's. It takes 1,000 men to invent a telegraph, or a steam engine, or a phonograph, or a photograph, or a telephone, or any other important thing. And the last man gets the credit, and we forget the others. He added his little mite. That is all he did. These object lessons should teach us that 99 parts of all things that proceed from the intellect are pelagisms, pure and simple. I should know what that is, but Mark Twain's more literate than me. Probably even now when he's dead, he's still probably better at talking than I am. And the lesson ought to make us modest, but nothing can do that. So, yes, that's a great quote. See, Mark Twain was one of those guys. He was one of those guys that could just, he had it. It's just one of those things. There's people that have it and people that don't have it. Da Vinci had it. Different people had it. There's no denying Newton had it. People have it. And even when they're not right all the time, especially the historical figures were trying their best in a tough environment, but like Benjamin Franklin types and stuff. And these people who want to tear them down to put up these, I'm not saying he's a complete charlatan, but come on, Tesla wasn't one of those men. Tesla did a little innovation to a whole system that Edison had already developed, or let's say Edison and his men, but clearly Edison he was the fulcrum, he was the key to the whole thing. And so, Edison made the first generator. Tesla improved it, and people don't even get that single fact right. And it's rude. It's being rude to dead people who aren't here to defend themselves from these fanatics. But anyway, and I really don't want to be a Tesla hater, but they just turn you into it because they just keep walking around like Jesus nuts or something, and you're just like saying, how many times do I have to say to these Jesus nuts that, when push was coming to shove, what was Jesus's famous line? The poor will be with you always. I am here for just a short while. Right? He was here longer than most of the humans of his time were here. He's whining about only being here a short while when that's all of us get is a short while. The same fucking short while. I mean, what kind of thing is it for a savior to come? The guy's coming to save you, right? Superman shows up from Kryptonite Town or whatever, and he shows up, I'm here to save the day. Except for the poor problem. I got no answer for that. You get me? Just shoot him. I mean, it's not worth the trouble. You're here to save the day, but you can't fix the biggest problem existing on Earth. Oh. And fuck you. Yeah, you're not Superman. You're not useful, man. But that's philosophy. We don't want to do that here. Too messy. Okay. Alright, let's see. Oh, here's another comment by Tony. I don't know if I already read it, but we'll do it anyway. Alright, so, he says $1 billion. Wow, I wish more people were outraged. What a waste of tax dollars. Yeah, like I said, it's all nice having one of these interferometers around to play with, but at the price tag, it's really insane when you think of what they could have done in science with $1 billion. Just think of the 2-slit experiment they could have done with $1 billion. They could have done some real science, this mush. Alright, Tony again. I honestly don't get how these schooled scientists can say things with such conviction. For instance, how do they know for a fact that the interferometer thing can detect waves? Well, the fact that it can detect vibrations is pretty... I was even thinking if there's different ways to do this interferometer thing, right? See, the key thing is they spend a lot of money, billions of dollars, right? So they spend a lot of money on this laser to make it as perfectly in phase as possible. Because most lasers, they have quite a bit of fluctuation in their phase. And so I could take a cheap green laser and a cheap red laser, and I could make an interferometer without a beam splitter. That is, I could just shoot the two beams and reflect them to one point. And in doing that, I could create what would look like white light. And as as the edges of that light, as those two beams got moved, okay, you could think that the phase of the light would change and the color would change. So it would go white and then less white, and it would get screwed up by the phase changes. In terms of its color, it would start to shift green or shift red, and you could detect that. So you could make one in different ways, where you're going to detect subtle changes in the distance that the beam travels. And it doesn't have to be an absolute distance. See, they also say with these interferometers, which is always a lie, because it really doesn't matter. The two tubes aren't exactly the same length. They really aren't. The two mirrors aren't exactly the same distance away from the beam splitter. Because that, when you think about it, would be fucking impossible. All they are is a similar distance, and they just make sure the beams are in phase. So they fine-tune it so the two beams are in phase. And now that'll be their neutral point, and then they'll see any variation off that neutral. But that's all they have to do, is get the two beams in phase or completely 90 degrees out of phase. But all they have to do is calibrate it. But they're not really doing the absolute perfect same distance thing. So there's lots of deceptions, and there's lots of potential misunderstanding created by the loose language they use in describing this stuff. It's very loose, sloppy, unscientific, unexact language. Alright, it seems like circular reasoning. Well, the part that seems kind of circular is they're theorizing about how thin a human hair they're detecting when they haven't really done any experiments to actually demonstrate that level of precision. Experiments like creating a fake noise somewhere, a vibration, and being able to detect it. You think they would have done more proofing of the precision and accuracy and delicacy of their instrument, besides just using it on their 5 billion light year away thing. That seems incredibly, it also seems just horribly unfortunate that black holes make a signal that looks an awful lot like what an earthquake does. That's a little bit unfortunate. They assume that gravity can make waves, then they see a blip on the Rager, R-A-G-E-R, I guess that's radar, I don't know, and go, oh yeah, that proves it, alright. Yeah, well, they see a specific kind of signal that, again, unfortunately looks way too much like what earthquakes do, which is rumble, 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 boom. Yeah. See, earthquakes go boom; they don't go chirp. You know, but it does the same thing. It goes boom. You know, so it doesn't chirp, but you can sort of understand that maybe their instrument can't tell the difference between chirping and booming. Oh yeah, that proves it, alright. Case closed. No need to look any farther. Nothing more to see here. Well, that's the really disgusting part, is that there's just no will for scientists to sit there and say, well, this is a pretty elaborate theory. It's got a lot of moving parts, okay? I mean, you're changing Einstein's equations, you're doing this little neutron star excuse for all of a sudden we can change a minus 44 into a minus 21. You know, we can cut everything in half and get rid of all that impossibility problem. You know, there's a lot of crap in this theory, and it just seems like this whole idea of 3 solar masses just poofed away and kind of went into being little force bits. And you know, I mean, if they said it was force bits, I could say, okay, they would be repulsive, though. That's what they would be. They wouldn't be attractive bits. See, that's the trick with gravity. You can't put more gravity on the outside to make more gravity. See, the pressure comes from the universe, and all you can do is reduce the pressure, and that's what gravity is doing. Gravity is a reduction in pressure, so it becomes a going in force. And it can't do repulsion because you can't make more force on the inside. You can only take force away on the inside. You can't bring it back out there. So that's why gravity can't be repulsive. Alright. Let's see. Case closed. No need to look any further. Nothing to see here. Please pay no attention to the man behind the curtain. Yes, okay, well, you know. 4 cliches is probably enough. But very good. Laughing my fucking ass off. Yeah, I wish I could laugh, because it just seems like this is a huge problem for the human race. They are just too stupid, and they just won't learn anything. I mean, that's why we're still, like I said, most of the human beings are clinging to some stupid story about Thor, you know, living in the clouds. I mean, fuck. It's just so pitiful. And the people who have a little bit of intelligence, they actually went to college and shit. You know, they looked at the word reasonable and saw a definition and stuff. That they're not just, you know, trivial thinkers. They won't even pay any attention. They're so fucking bored. Ugh. So, anyway. So yeah, that's it for the comments. So I don't need to drag on about stuff. I really, like I said, kind of want to do the little videos about little points along the way, like take a few sentences at a time what I've written, and just explain those few sentences in a short kind of video that somebody can click on if they need more information, that kind of thing. Just do this in some kind of way where somebody doesn't get this automatically. You know, it doesn't automatically say to them, oh yeah, this means this. You know, and once you have this, it means if I put another thing in here, then they've got shadows, and shadows mean less pressure and things move together. Yeah, that's how it works. So anyway, yeah, so thank you. At least reasonably articulate comments. I could understand most of what was stated. Didn't like some of it, but, you know, you don't exist to produce what I like, and I don't exist to hear what you like, or something like that. But anyway, till the next time. Such.